We have learned from our previous discussions that circular curves are being used in horizontal aspect of highway and railroads. In this video, we will discuss the use of parabolic curves in construction of vertical highway curves. So what is a vertical curve? A vertical curve are used in highways and street vertical alignment to, to provide a gradual change between two adjacent grade lines. So here we have the vertical curve using the principle of parabola. So we have the following elements. We have the PVC, or the point of vertical curve. We have the PVI, the point of vertical intersection, and we have the PVT, or the point of vertical tangency. We also have here the grade lines. We have the back tangent grade line and the forward tangent grade line. So the grade lines G1 and G2 are measured in percentage. So we have here the following elements. So why are we using parabola in the geometric consideration of vertical curves? Parabola is being used for the following reasons. Number one, we have the ease of computation. Two, we have the uniformly changing slope of curve. Number three, we have the properties of vertical curve, or the parabola, which are the following. Letter A, the vertical offsets from the tangent to the curve are proportional to the squares of the distances from the point of tangency. So what does it mean? If this is the curve, we have the vertical offset denoted by the capital letter H. So we have H, or the vertical offset. So this is the distance from the curve to the intersection of the tangent lines, or as well as this distance from the curve to the line connecting PVC and PVT. So it says that the vertical offset are proportional to the squares of the distances from the point of tangency. So if we have here H is proportional to the horizontal distance from the point of tangency. So we have H is to L over 2 squared equals, let us say, we have here y sub 1 is to x sub 1 squared. We also have y sub 2 is to x sub 2 squared, and y sub 3 is to x sub 3 squared, and so on, as shown on the figure. Second property, the curve bisects the distance between the vertex and the midpoint of the long curve. What does it mean? So the curve bisects the distance between the vertex and the midpoint of the long chord. So this one, we have here, if this is B, this is F, this is C, this is D, we have BF, or the line BF is equal to half the line CD. So if this is BF, this is CD, we have BF equals CD over 2. Next property, we have the algebraic difference in the rate of the grade of the two slopes is positive. We have a sag curve, otherwise we have a summit curve. Or positive algebraic difference is a summit, otherwise we have a sag curve. So what does it mean? When you have your G1 to be positive and G2 to be negative, we have a summit curve. While if your G1 is negative and G2 is positive, we have a sag curve. Next property, the length of the curve of a parabolic vertical curve refers to the horizontal distance from PC to PT. So we have here the length from PVC to PVT. So this is the length of the parabolic curve and not the curve length. So we have here L over 2, we have here L over 2. And the stationing of any point at the parabolic curve is not measured along the curve, but is measured along the horizontal line. For example, we have the station of PC and or the PVC, and you have to solve for the stationing of PVI. We have to add L over 2 to PVC in order to solve for the value of PVI. So those are the properties of parabolic curves. Parabolic curves can be symmetrical or unsymmetrical. Symmetrical curve, as shown on the figure, wherein the length of the right side is equal to the length, or the length of the right side is equal to the length of the left side. While unsymmetrical curve has length of the left side L1 not equal to the length of the right side L2. So therefore the length of the curve is L equals L1 plus L2. PVC, PVI, PVT. And that gives us an introduction to the vertical parabolic curves.